Simplification of surds, basic form. If the rational number under the square root sign contains a factor which is the square of a number, the surd can be reduced to a simpler form. Such a simpler form is called its basic form. So all these numbers under the square root sign, apart from this number, this and this, they are all rational numbers in the sense that they are exact. They are rational numbers. But since they are under the square root sign, they can be reduced or they can be simplified. So when we attempt to simplify a rational number under the square root sign, we call that the basic form of a surd, because at the end of the day we're going to arrive at a value and a square root of a non-rational number, or a square root of a non-perfect square. So what I mean is this: if we have, when we have let's say 90, we have the square root sign. 90 is a rational number, is an exact value. So if we are simplifying this, we're going to have say 9 times 10, which is the product of 90, and that will give us 3 root 10. So this is what we're going to have. That's the simplification of this figure or surd. So what I did is what this right of is explaining. It says if the rational number under the square root sign contains a factor which is the square of a number, the surd can be reduced to a simpler form. So this is surd, because if you're to get the value of root 90, you're going to have values that are not ending to continue indefinitely. So we can simplify this, and when we simplify this, we'll get to this form. But how do we get there? So let's finish what we have here. So the surd can be reduced to a simpler form. Such a simpler form is called its basic form. So to simplify a surd, where possible, express the number under the square root sign as a product of two factors. That's the last class, the last lesson. I explained that whenever you need to simplify a given surd, you must get two factors of that particular number, out of which one of them must be a perfect square. So that was what I did here. 9 times 10 will give me 90. I could as well use 45 times 2, which is also equal to 90. But the problem here is that neither this nor this is a perfect square. So I wouldn't be able to simplify one of them if I had used this. So assuming say root 90 is equal to root 45 times 2. Now, there was no way I could have gotten the square root of 45 and square root of 2, since both of them are irrational. Since both of them are non-perfect squares. So the square root of 45 will give me an indefinite values that are indefinite, and also square root of 2 will give me values that are indefinite. None of them will give me exact values, unlike in this case where I use 9 times 10, these two factors of 90. Here root 9 times root 10. And of course now root 9 will give me an exact value, which is 3. But only root 10 will give me an inexact value, or values that have no ending. So I'll simply leave it as root 10. So this is the simplified form of root 90. So the rule is to simplify a surd where possible, express the number under the square root sign as a product of two factors, one of which is a perfect square. Is a must. One of the products must be a perfect square if you must be able to simplify a given surd, which is what I did there. Then simplify the surd by taking the square root of the perfect square. Once you get the two factors, out of which one is a perfect square, you're going to take the square root of the perfect square, which in this case is 9. So root 9 is 3, or square root of 9 is 3. So 3 times root 10 will give us 3 root 10. That's how you simplify a surd. And when you simplify a surd in that way, we call it the basic form of the surd. So let's see what the examples here, the simplification of these examples will give us. So solution A root 45. Root 45 will give us we going for 45. Factors of 45 are 15 times 3 and then 9. 45 equals 9 times 5. 15 times 3 is equal to 45. 9 times 5 is 45. Now look at this. These particular factors, 15 is not the perfect square. 3 is not the perfect square. So if we have root 15 times root 3, we would not be able to get exact value for 15, and neither would we be able to get the exact value for 15, nor would we be able to get exact value for root 3. So what do? We can't use this. Rather, we're going to look for other factors of 45 where one of the factors is a perfect square, and this is exactly what we need. So root 9 times root 5. So come here and say 9 times 5, which should give us root 9 times root 5. And then of course we can get the exact value for one of the roots, which is root 9. So root 9 is 3, root 5 still a root 5 is a non-rational number, so we cannot get the exact root. While root 9 is a rational square, it's a perfect square. Rather, this is a non-perfect square, so we can't get an exact value for it. So it's the root that is a perfect square that we can that we need to get the square root of, which the statement here says, then simplify the surd by taking the square root of the perfect square. This is why we insist that one of the factors of the surd must be a perfect square, because we must be able to take the square root of that perfect square. So these are basic form of this surd to be 162 square root of 162. So for 162, products of 162, I'm going to look for two factors of 162 and multiply them together. So let's see, 162 would have 54 times 3, and 162 will have 81 times 2. There could be other, there are other factors, but I want to limit the factors to just these two. Yeah. And so let's analyze 54 times 3. This is not a perfect square, and this is not also a perfect square. This is a perfect square. This is a non-perfect square, so we are going to go by this. So this will give us 81 times 2. That's root 81 times root 2. Now root 81 is the perfect square. We can get the square root of root 81, which is 9. So 9 root 2. So final answer C root x squared y. So this will give us root x squared times root y, and then this is root x squared times root y. Already this is a perfect square, so x squared root x squared is going to give us, remember indices, root x squared is equal to x squared is to 1 over 2, where this symbol for roots is 1 over 2. So, and of course, if you go by, this is also 2, which is a power, and this is also a fractional power. So 2 times 1 numerator multiplied numerator will give us x raised to 2 over 2. So 2 here 1, 2 here 1, and that's equal to x raised to the power 1. And anything raised to the power of 1 is that's similar. So that's x. Then if you don't want to go by this, you can simply say root x squared. So this square root, this power will cancel the square root sign, which will give us x same thing. So this will give us x root y as our final answer. D 3 root 50. This will give us 3 times root 50. Factors of root 50 are 50, can have 5 times 10, and 50 we have 50 times 1, 50 we have 25 times 2. Neither this nor this is a perfect square. Neither this nor this is a perfect square. This is a perfect square. So we're going to take that. That will give us 3 times root 25 times 2. So we have 3 times root 25 times root 2. And that will give us 3. Square root of 25 is 5 times root 2. So 3 times 5 is 15. 15 times root 2 will give us root 2. 15 root 2. So these are the basic forms of the following surds.